Okay, guys, so new chapter. Yesterday, you did the brain pop and you were kind of introduced to the whole idea of speed and motion and how to calculate that. Today, we're going to be talking a little bit more about that and graphing as well. So, first, defining a couple terms. Motion, we're probably really familiar with that. We know what it means to move something, but basically it's changing a position relative to a reference point. And what that means is a reference point is anything that you're using um, as your point to compare to. So if you're the reference point, right, your eyes are saying, okay, this car moved from this side of me to this side of me. I know it moved. If the reference point is a checkered flag, knowing you went around one lap. So any point that you can use to determine whether or not something has moved or not. Displacement is the distance and the direction of an object's change in position. So this does not mean, like, let's say you go around a complete lap. The distance of the lap is not your displacement. That is your distance. Your displacement is the measurement from where you started to where you ended. So where is the change of location at that point? And we're going to be looking at displacement a little bit more here in a second. Okay, so now looking at the idea of displacements. So first, let's look at our distances. So we traveled 5 meters east and then traveled another 5 meters east, right? So our total distance is 10 meters east. That makes sense. Our direction is east. Your displacement is how far was your starting point to your ending point. That's 10 meters. So in this case, our direction and our distance and our displacements all line up. But sometimes our displacements are different than our distances. So we're going to look at that too. So now look at this one. Let's say that you walk 10 meters east and then 5 meters west, right? So you walked a total of 15 meters. That would be your total distance. However, remember, displacement is just worried about the change in position. So where did you start and where are you now? So technically, from your starting position, you're only 5 meters east because you went 10 meters east and came back 5 meters west. So you're 5 meters east of your original location. So if this were a test question, it asked you, what is your distance? Your distance would be 15 meters. Your displacement would be 5 meters east, because with the placement, you have to tell me the direction. Here's another one, right? So let's say you traveled 4 meters east and then 3 meters north. Distance is a total of 7 meters, but displacement is just where did you start from where did you end? And the quickest way to get there would be to draw a straight line from that one point to the other point, and that would equal 5 meters. You haven't quite learned yet, because you're not in Algebra 1, how you would get that 5 meters, but if it was labeled for you, know that that is your displacement. So now, I told you guys it was coming, math and science. And tomorrow you're going to be doing an assignment that's essentially a math assignment in science. I know, so much fun, but it's not hard. So calculating speed. Speed is the distance over a specific amount of time, right? So when we're driving in the US, we use miles per hour, right? So distance, miles over a unit of time, hour, right? In science, we use metric. So typically in this class, we're going to be using things like meters per second, um, millimeters per second. We're never going to use customary. So that's exactly what you do. You divide your distance over your time, just like miles over hours. So when you are given a speed, you can use it to calculate either the distance or the time, or vice versa. This is just what we did before when we did algebra. When we're solving for a variable, you won't be given 3 missing variables at a time. You will have 2 of them and you'll need to find the other one. So just a little review of how we do that. So here is a practice problem for you. And yes, you're going to see math problems like this on your test, but again, not that hard. Just follow along with me. So a car is traveling at a constant speed that covers a distance of 750 meters in 25 seconds. What is the car's speed? Well, you have your formula and you know that speed is just distance over time. So you take that distance and you put it over your time. So for this problem, if we had 750, right, meters over 25 seconds. Go ahead and divide that. You would end up with 30 meters per second. There you go. So now we're going to talk about changing speed, right? Because when you're like, imagine driving a car, even riding your bike, etc. You don't just go at a constant speed all the time. Sometimes you do, if it's programmed to go and stay at a constant speed, but typically you don't. And so we're going to talk about graphing as well. So if you graph speed versus distance, and what that means is you have speed on one side of your graph and distance on the other. If you look at the graph we have over here on the right, um, you can look at the slopes to tell if you're speeding up or if you're going down. So if the line is accelerating upward, like that first part that says gaining speed, good, you're going up. Um, if you stop or you're going at a constant speed, it's going to be like a straight line. Going down is decelerating. So you can see there that big drop where it says stopping at a red light. So this is something where on a test you might see a graph like this and you might be asked to label the point where the speed is increasing versus the point where the speed is decreasing, or the point where the motion has stopped or it's at a constant speed, which just means that the speed is not changing. It's going the exact same speed for whatever period of time. Okay, so just like we calculate averages in math, we calculate averages with your grades. We do the same thing with speed, right? So we know the speed formula is distance divided by time. So if you want to find your average speed, you're going to do that. You're just going to take the values from the whole trip, right? Um, so it describes motion that's been changing, right? So over like your total trip or so, and you want to know what is your average speed over your total trip. You're going to take the total distance that you traveled, right? And divide it by the total time that you traveled. And that's just going to give you an average estimate of about what your speed was. So now we have another way of graphing motion. So the other one was speed versus distance, and that showed you basically if you're speeding up, slowing down, stopping, or going at the same speed. This is a distance versus time graph, and we're going to be coming back to these multiple times. So familiarize yourself with this. This is used to show you your speed with something called a slope, other things you'll learn in Algebra 1, or maybe you've seen it before. But basically, a slope is just how steep a line is. So if this line is like sharper, more straight, and more steep, like that red car there, that means that you have a bigger slope. That means that you're traveling faster. The closer you are to a straight line, um, that means that you're going at you could be stopped or constant. So um, this is just to show you in a certain amount of time what's the distance that you're traveling, so you can use this to pick a speed at a certain point. So this is just showing you how you would do it. This is the same graph we just looked at. If you were to graph distance versus time, and you wanted to graph the motion of something to see which one's going faster or not, what you're going to do, and we've done these graphs before, but just a little reminder, you'll put your distance on the left side, you'll put your time on the bottom, and make sure all your numbers are evenly spaced. Like you can see here, even though they went by twos, it's evenly spaced. The ones they didn't number are just ones. You can go by any unit that you want, long as they're evenly spaced. Then you're going to find where the points meet. So when you're at distance 1, how much time did that take? When you're at distance 2, how much time did that take? Right? And then you're going to put those dots there and connect your lines. So this is what I was explaining to you about how the steeper line is going to be the one with the fastest speed. So look at these three lines here, and they look similar to the ones we just looked at. You see how they graphed their distance versus time graph. They put the distance on the left. You can see here now they're not going simply by 1, they're going by 200, but you can see each block is evenly spaced out. Each block represents 200. On the bottom, same thing this time. It looks like they went by they skipped by tens, but if you count in between, you can tell that the spaces are evenly distributed as well. So now looking at the three lines, trying to figure out who was the fastest. That would be Mary. She had the steepest line, which means that she traveled the furthest distance in the shortest amount of time. So if you were to calculate the slope of that line, that would give you her speed. And you can see they labeled the speeds there for you, and that's the kind of thing you would see because you haven't learned to calculate slope yet. And that is lesson 12.1. So go ahead, finish your notes, and then there is a video I want you to watch and take notes on, and you're done.